composite or prime. Prime numbers. Prime numbers are counting numbers greater than 1 that can be divided only by 1 and itself. In other words, it has no other factors other than 1 and itself. Notice greater than 1. Composite numbers. Counting numbers with more than 2 factors. Special numbers. Counting numbers which are neither composite nor prime. For example, 1 and 0 are considered special numbers. They're not prime and they're not composite. If you look in the definition of prime numbers up here, I've underlined the word only. That's the only way to get a prime number is multiplying 1 in itself. And special numbers, neither composite nor prime. In other words, special numbers are not considered composite and they're not considered prime. Let's take a look at some numbers and determine if they are prime, composite, or special. 0 is special. 1 will also be considered special. 2. The only way to get 2 is 1 times 2. So its only factors are 1 and itself. So it is considered prime. 3 is 1 times 3. Its factors are only 1 and itself. So it is prime. 4 can be found by multiplying 1 times 4 and 2 times 2. Since there is another pair, it is composite. It's not only 1 times itself, it's also 2 times 2. 5 is 1 times 5. That makes it prime. 6 is 1 times 6 and then also 2 times 3. That makes it composite. And 7 is 1 times 7 and therefore it is prime. Notice that the prime numbers, you can only get it multiplying one way, 1 times itself. 1 times 2 gives you 2, 1 times 3 gives you 3, 1 times 5 gives you 5, 1 times 7 gives you 7. The other numbers, 2 or 4 and 6, are composite because there are other ways to get it. Take a look here. 8. 1 times 8, 2 times 4. That makes it composite. 9. 1 times 9, 3 times 3. That makes it composite. 10. 1 times 10, 2 times 5. It's composite. 11 can only be found 1 times 11, so it's prime. 12 has 3 different ways, so it is composite. 13 can only be found one way. It's prime. 14 has 2 ways, so it is considered composite. And 15 is composite as well. There's something called an Eratosthenes sieve, which is a way to determine the list of prime numbers. Okay, I've got this grid going from 0 to 149. We're just going to work up to there. You can continue this for numbers above 149. So the first thing we're going to do is we're going to box off 0 and 1 because they're special. Okay, we'll circle the 2. It is the lowest prime number. Now we cross out all multiples of 2. 4, 6, 8, 10, 12, 14, 16, 18, and so on, all the way through the list. Now we circle the 3, which is the next prime number. It's the only one without the next one without an X. Now we're going to go through and multiply, cross out all the multiples of 3. 6, 9, 12, 15, 21, 24, 18, so on through the whole list. Okay. The next smallest number is 5. We'll circle it. It's the next prime number. Now we'll go through and we will cross out all multiples of 5. 15, 25, 35, and so on. Plus the 10s, the 20s, they were already crossed out because of 2. Okay. And we'll continue in like manner Circling the 7, crossing out all multiples of 7, circling the 11, all multiples of 11, 13, so on, 17, 19. Okay? Until the only thing left are the prime numbers that are circled. All the numbers that have x's through them are composite numbers because they can be found by other ways besides 1 times that number. 0 and 1, of course, are special numbers. So the ones with x's are composite, the ones that are circled are prime, and then, of course, the boxed ones are the special numbers.